From the earliest dawn of human consciousness, our story has been one defined by movement. By walking across continents and sailing across vast oceans, we have expanded the boundaries of what is possible. Yet, for most of history, the concept of a map as we know it, a printed, standardized representation of space, was an almost unimaginable luxury. Before the age of cartography and satellite imagery, how did humanity manage this fundamental act of exploration? Navigation was not a single unified science taught in academies. Rather, it was a sprawling accumulated body of highly localized knowledge. It resided in oral traditions, in star patterns memorized by generations, in the subtle shifts of ocean currents, and in the intimate understanding of local flora and fauna. To navigate was to be an expert ethnographer, meteorologist, astronomer, and linguist all at once. The blank canvas before early voyagers was not empty, it was simply unknown to the modern mind. It demanded a profound connection to the immediate environment, turning every passing cloud and every shifting tide into a crucial piece of navigational data. From the subtle cues of the ocean itself, early navigators extended their senses upward. The heavens offered an infinitely reliable clock and compass, provided one knew how to read its intricate script. Celestial navigation was perhaps humanity's most profound attempt at cosmic mapping. By observing the predictable movements of stars and the sun's zenith, skilled mariners could determine their latitude with remarkable accuracy. They tracked constellations like Ursa Minor, using Polaris, the pole star, as a steadfast guide point. The rising and setting points of specific celestial bodies provided an angular measurement against which their position could be calculated. This knowledge was not intuitive. It required sophisticated instruments such as the astrolabe or the quadrant. These tools allowed observers to measure the altitude of heavenly objects, transforming raw observation into precise mathematical data. Mastering this art demanded rigorous training, deep astronomical understanding, and a meticulous patience that few modern lives require. It linked human endeavor directly to the immutable laws of physics and the rhythm of the cosmos. This mastery allowed voyages across vast, featureless oceans with confidence. The celestial sphere became their ultimate. But even when the stars were obscured by cloud cover, or when the vessel was caught in a fog bank, navigators relied on something far more immediate: the ocean itself. This required an almost intuitive reading of the environment, a deep knowledge that transcended mere calculation. They understood the subtle language of the water's color, recognizing shifts in hue that betrayed changes in depth or underlying currents. A sudden darkening could signal a shelf drop-off, while unusual foam patterns hinted at powerful underwater flows. Bird flight paths became vital indicators. Specific species and their consistent routes often meant proximity to land, even if it remained hidden on the horizon. And of course, there was the wind, the predictable yet complex rhythm of the trade winds that formed the backbone of global travel. This knowledge base wasn't just academic. It was a survival skill, passed down through generations, transforming raw observation into actionable intelligence. It was the ocean's whisper, interpreted by human expertise. Mastering these signs demanded rigorous observation, a skill honed by countless voyages. They tracked subtle changes in wave patterns, noting how swells interacted. But even with an intimate knowledge of celestial bodies and prevailing currents, navigators faced the constant challenge of predicting their own location. This required a technique known as dead reckoning. Essentially, it is the process of calculating your current position based on where you were previously, how fast you believe you are moving, and how much time has elapsed. It was an intellectual exercise in estimation. On land, this might involve careful pacing or timing travel between known landmarks. At sea, techniques evolved to estimate speed using drift logs or meticulously timed observations against the water's movement. The brilliance of dead reckoning lay in its simplicity. It required only basic measurements and a steady hand. Yet it was inherently fragile. Every slight misjudgment of current, every gust of wind underestimated, contributed to cumulative error, pulling the plotted course further from reality. Constant vigilance and systematic correction were therefore not optional. They were the very foundation of safe passage. These cumulative errors demanded constant triangulation against known points of practice that kept navigators grounded in reality. Only by cross-referencing these estimates with observed bearings could they hope to maintain a true course toward their distant destination. The sheer volume of data required for such voyages was staggering, far exceeding the capacity of simple memory alone. How did knowledge of vast ocean currents, changing stellar alignments, and thousands of miles of coastlines survive across generations? The answer lay in the profound power of oral tradition. This wasn't merely storytelling, it was a sophisticated mnemonic technology. Navigational data was encoded into chants, epic voyages, and intricate songs, oral histories that served as living atlases. These poetic structures provided rhythm and rhyme, allowing complex sequences of bearings and timings to be memorized with incredible accuracy. The stars themselves became characters in the narrative, and wave patterns were woven into verses. By mastering these cultural forms, the navigators ensured that their accumulated wisdom remained vibrant, accurate, and transferable, linking the knowledge of ancestors directly to the hands of their descendants thousands of miles from home. These chants often included detailed star compasses and specific directional markers, a cosmic map sung into existence. This rigorous pedagogical method transformed knowledge from perishable memory into enduring cultural law, ensuring survival across time and distance. Beyond the printed page lay a mastery of navigation rooted not in paper, but in profound observation. For millennia, cultures across the Pacific and along continental waterways developed sophisticated systems that treated the environment itself as the primary map. Consider Polynesian wayfinding. It was an intricate science built on reading subtle shifts in swell patterns, the flight paths of migratory birds, and the precise position of constellations rising over specific islands. These navigators did not merely follow a path, they internalized the entire oceanic landscape. Similarly, indigenous knowledge systems integrated seasonal cycles, understanding how river currents changed with rainfall, or tracking game trails that revealed hidden coastal geography. This was never just about getting from point A to B. It was a holistic survival art, a deep cultural repository, where celestial mechanics, botany, and oral tradition were inextricably linked. The journey itself became the curriculum, ensuring that knowledge remained not just accurate but deeply lived. From the Amazon's tributaries to the Arctic ice edge, this mastery persisted. These deep ecological memories allowed communities to thrive in seemingly hostile environments, proving that true cartography resides within human experience and collective wisdom. This profound reliance on embodied knowledge was supplemented by physical tools, artifacts that helped codify the unwritten rules of the sea and land. We are looking at a transition point, from pure memory to material aid. Early navigation did not begin with standardized printed charts, it began with simple, specialized instruments. Consider the earliest compass designs. While the magnetic needle is often associated solely with China, similar principles of directional awareness were independently developed across multiple cultures, suggesting a profound understanding of geomagnetism that predates unified scientific theory. These early devices range from magnetized lodestones to more sophisticated floating pointers. Beyond direction, navigators use specialized measuring tools, be it calibrated sighting sticks or weighted plumb lines, to determine latitude and depth with remarkable accuracy. Furthermore, rudimentary charts often served less as precise geographical records and more as mnemonic aids, stylized diagrams of currents, seasonal wind patterns, or critical landfall markers. They were practical guides designed to jog the memory and reinforce the oral tradition that was their true source of power. These early guides were often etched on treated animal skins or carved wood making. The truth, however, lay not in any single instrument or chart, but in the synthesis itself. The most successful navigators understood that no technique was infallible on its own. Celestial observation provided latitude, yes, but it offered little of longitude. Dead reckoning could track movement, yet failed to account for unpredictable currents or sudden shifts in wind patterns. Environmental awareness, reading the subtle color changes in the water, noting the flight path of seabirds, or interpreting the smell of distant land, provided the vital context that numbers lacked. To maintain a course over vast, featureless expanses required an integrated knowledge base. The scientific rigor of celestial mechanics merged with the accumulated lore of generations. It was a dynamic art, requiring constant adaptation and deep observational skill. The navigator became less a cartographer and more a living repository of environmental data, weaving together astronomical readings, estimated movement, and empirical wisdom to plot a course across the unknown. This holistic mastery allowed them to predict seasonal shifts and adjust their routes proactively. Their knowledge was a living science, a profound dialogue between man, sky, sea, and earth. The enduring compass is not merely an instrument, it represents a fundamental human capacity for understanding place. While today's global positioning systems offer unparalleled precision, they are sophisticated tools built upon principles that have remained constant for millennia: observation, pattern recognition, and the deep comprehension of one's relationship to the environment. The skills honed by ancient navigators reading wave patterns, interpreting stellar alignments, or discerning subtle shifts in wind direction are not lost arts, they are foundational human competencies. They represent a profound dialogue between man and nature that technology can assist but never fully replace. This deep embodied knowledge is a resilient form of intelligence. It reminds us that true mastery of movement requires more than coordinates, it demands an acute awareness of the world around you. The wisdom of wayfinding endures, proving that humanity's most reliable compass remains within itself. From Polynesian wayfinders tracking currents by scent to early explorers charting coastlines by bird flight, this embodied knowledge persists. It is a testament to human adaptability, a wisdom that guides us beyond mere technology, anchoring us in the enduring rhythm of our planet.